During the last decade, there has been an explosion of data published on the web. Not necessarily textual content or media files, but structured or semi-structured data from various domains: finance, life sciences, demographics, and many more. Data.gov, the US government's open data portal, was created in 2009 with 47 datasets. It now holds more than 130,000 datasets. Its creators report that open data is fuel for innovators. According to a recent study, it has the potential to generate more than $3 trillion a year in additional value in numerous economic sectors. In the European Union, the situation is similar. Most governments have announced and implement plans for publishing open data. Organizations and science institutions participate also in this data publishing marathon. Moreover, a lot of this data, our linked data, the LOD cloud, has also been expanding these years.
The main motivation for the Diachron project is the rapidly changing landscape of data in many dimensions, and it's primarily a space-time issue. Too much data refers to space, and rapidly changing data refers to time, and changing with respect to syntax and format, but also semantics. And all that is happening when the kinds of data that are now widely available is beyond simple objects, but goes to structured objects and also to linked objects. And in this environment, there are several needs that need to be addressed and challenges that need to be resolved. Such data needs to be preserved for various reasons: accountability, provenance, and historical memory. Such data needs to be accessible and findable after it's preserved for time travel queries or longitudinal queries, plus also pure historical queries, and needs to be of high quality. The Diachron project is working towards addressing these challenges, and there are several technical issues, scientific issues that are deep and difficult that are being resolved. Issues of change representation and management, change detection and notification of when it happens, issues of versioning, data curation, data cleaning to achieve the quality necessary, and of course querying all the data that in the ways that are necessary.
Biological data evolves all the time. It evolves because biological knowledge changes. That means that we have different sets of properties about data, so the things that we know about a gene's function will change. The location of a variant might be mapped to a different place in the genome, or the function of a compound in a biological system, the understanding of that will change. And practically, that means that we're having to evolve data all the time. We want to make sure that the data are not broken, and we also sometimes want a longitudinal view on the data, so we can see when the knowledge changed and then decide how to change the representation. So Diachron is a really interesting project for us because Diachron is allowing us to take longitudinal views over our data and see how the data has evolved, detect changes in the data, and work out if those changes were the result of a process that we engineered or a process that is really a genuine data evolution process, and to detect the changes, and the vision is really to automatically repair the changes. So if we get changes of a certain type, through the services of Diachron, we'll actually be able to repair the data, and this means that we'll have to do less manual curation work, and our very smart domain area experts will be able to be smart domain area experts and not repairing holes in our data.
So how we do it? How do we manage and understand the evolution of data? How do we preserve the data for future use? Let us assume a simplified example, a very small part from a life science ontology. The DNA concept, which of course is described by a set of properties. This entity is part of a larger data set. For example, a life science ontology. Naturally, this ontology is continuously edited by its authors, and as data entities evolve, a property might be added or deleted or edited. These changes are published as new versions of the ontology. The Diachron approach treats all versions of the dataset as equal by keeping them easily accessible and not stashed away in a locked storage system. The changes between them are also there. You can query the past versions of a dataset as you would with the current version. You can even query the complete timeline along with the changes. But Diachron is more than that. It provides tools for accessing the quality of the datasets under various aspects by calculating multiple metrics. Data mistakes and other anomalies can also be detected and repaired. So Diachron is a set of tools implemented as web services for ease of use, integrated in one platform. And during the project's life cycle, this platform will be tested by 3 pilot applications